Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-Tri-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. Let's look at balancing chemical equations when you have a combustion reaction. Combustion reactions all look the same. You'll have a complex or some type of organic molecule on the left, and there will always be a reaction with oxygen. It's diatomic, so it'll be O2, oxygen gas, and the products of combustion are CO2 and water, carbon dioxide and water. So our first example in balancing these types of equations, let's take methane, which is CH4. If you start, if you remember the rules, which are down here, it says to leave your diatomic molecules for last. So you want to leave your oxygen for last. That might help you in balancing. And rule number 3 is start with the most complex, which will be your organic molecule, in this case, methane. So with those two hints is a good way to start with combustion equations. Let's start here. We have one carbon molecule here. Look on the other side, we have one carbon, so that looks balanced. Then we have 4 hydrogen in this molecule. So we go over to water, and in order to get 4 hydrogen for water, we need to add a 2 in front of the water molecule. Now all that's left is oxygen. On this side, carbon dioxide, we have 2 oxygen atoms. And with water, each one has 1 oxygen atom, but we have 2 waters. So that's 2 oxygens. Add those together, you have 4 oxygens on the right. To get 4 oxygens on the left, we would put a 2 in front of the diatomic oxygen molecule here. And now you're balanced. So if we move on to a more complex molecule, we'll go across here. Let's try and do butane. Butane is C4H10. Let me write that better. So again, using the same rules, we're going to start with the butane. We have 4 carbon atoms now on the left. So in order to get 4 carbons on the right, we'll put a 4 in front of the carbon dioxide. Now we do the hydrogen. We have 10 hydrogen on the left. So to the water molecule here, in order to get 10 hydrogen, since each water molecule has 2, we would put a 5 in front of the water molecule. So now hydrogen is done. But if we look at the oxygen now, with carbon dioxide, we have 4 molecules, each one has 2 oxygen. So we have 8 oxygen and carbon dioxide. And then in the water molecule, we got 5 water molecules. That gives us 5 oxygen molecules. Total here will be 13. Should recognize immediately 13 is an odd number. We're going to have a little trouble here when we come back to try to get to 13 oxygen molecules when we have a diatomic here, O2. A simple way to look at it is to put it 13 over 2. In order to get 13 oxygen molecules, we have to multiply O2 by 13 over 2. In other words, really this is saying we need about 6.5 oxygen molecules in order to get 13 oxygen. Now, should be aware our coefficients on all our molecules here have to be whole numbers. So if I eliminate this to eliminate confusion here a little bit, if we bring in rule down number 4 here. Rule number 4 is whenever we end up with partial atoms or molecules or needing partials, then a way to get a balance is to look at the entire equation and try to use a common factor of multiplication. So in this case, if we look at the whole equation and if we multiply it by 2, the 2 will cancel out the division of 2 here and will give us 13 oxygen molecules. And you'll see that that will end up helping us balance. So now if we do the whole equation by 2, the new equation we have is C4H10. We're going to have 2 butane molecules. You're going to have 13 oxygen molecules. We're going to take 2 times 4. We're going to have 8 carbon dioxide molecules and now 10 water molecules. And we should see, I'll switch to another color here for you. Maybe now we should balance. So let's start again. For carbon, on this side we have 8 carbons, 2 times the C4. And on the right we have 8 carbons. So the carbons balance. The hydrogen, we have 2 molecules each with H10. So we have 20 hydrogens over here. We go on the right here. You have 10 times H2. You have 20 hydrogens. So that balances. Now when we look at the oxygen, we have 8 carbon dioxides. Each one has 2, so that's 16 oxygen for carbon dioxide. And then for the water, 10 times a single oxygen. We have 10 oxygen for a total of 26 oxygens. And then if we look back on the left now, 13 molecules of O2 is 26 oxygens. And now we're balanced on oxygen and for the entire equation. So in combustion equations, you'll commonly find that you're going to need this multiplication factor or this step number 4 here in the hints in order to get a balanced equation. Thank you.